Welcome America Smiles members, America Smiles customers, and those of you who may be new to America Smiles. In today's video, we're going to be discussing Zirconia scale factors. It's that exact scale factor that you see on every unique disc that you buy to put into your mill. So today we're going to discuss what is the actual scale factor, how does the Zirconia disc manufacturer, that's us, arrive at that specific number, and how does the scale factor can actually affect your milling processes and ultimately affect the fit of your crown. So what is the actual scale factor? First of all zirconia begins simply as a bag of powder. We buy it comes in a 20 kilo container, and we're going to take this powder and we're going to press it into a disc. So this powder is placed into our press and pressed into the shape of the disc that you require for your actual milling machine. Ultimately, a tooth, once you get it, a tooth is going to get dug out of this disc, and it's going to be placed into your sintering oven. At roughly 1200 degrees centigrade, that zirconia is going to shrink to an absolute known factor. The factor being from the powder state to coming out of getting into your sintering oven at 1200 degrees, it's going to shrink an exact known total percentage of its original size. All shrinkage is completed well before your final curing temperature so that you never impact the fit or the shrinkage of the crown. So all the shrinkage takes place at about 1200, but as you know, you're taking your zirconia upwards of about 1500. That gets the final appearance and all the final aesthetics out of it, but again, all shrinkage is done and completed at about 1200. So the shrinkage factor tells you exactly how much your zirconia tooth is going to shrink in your sintering oven at 1200 degrees. But here's the problem. We don't just take a disc and we don't just press it and send it right out to you. That would be easy if we can do that. But at this point in time, the zirconia is way too soft. If we just pressed it and sent it to you, your mill would just turn the teeth into powder. You would never even be able to get a tooth out of it. The zirconia is just way, way, way too soft. So what we do is we partially bake that disc in the oven to make it strong enough to survive the milling process, but not make it so strong that it's hard on your machine, hard on your spindle, and ultimately even destroying your tools. So we have to try to strike a nice, perfect balance where we cook it just enough so that you can mill and actually harvest a tooth out of there, and not cook it so much that it's doing harm to your machine or your tools. So how do we get that specific scale factor number? That in itself does create a bit of a challenge. Since we partially bake all of our discs, each disc is partially baked relative to the total final shrinkage that's going to take place. So essentially you could say, if you shrink it all the way, we shrink it about halfway. So by the time you get the zirconia, it's a portion of that shrinkage has already been taken off, and you're going to finish the rest of the shrinkage. But here's the problem. We have 3 ovens, and not all 3 ovens fire the same. As a matter of fact, we have one known oven that runs just a little bit cooler, so we actually have to cook the zirconia a little hotter in that oven. Within that oven, there's 5 shelves. Not all 5 shelves cook the same. And we even discovered that the discs that are closer to the edge will actually cook a little bit hotter than the discs that are closest inside the middle. So with all these variables, from ovens to shelves and location within the shelves, what we really know is if we put 100 discs in an oven to cure them, they don't all have the exact same experience. Every disc has its own unique experience. So theoretically, some discs shrink a little bit more in our possession, and some discs shrink a little bit less in our possession. So what do? How do we gather all this data and communicate to you so you know, hey, how much did we shrink the disc? What we do is every disc that comes off of the press, we capture at least 4 data points. Primarily, we're measuring the disc dimensions, and then we're also measuring the disc weight. And this data is documented prior to putting the disc into the oven. And then when that disc comes out of the oven, we identify that exact disc by location in the oven. We associate it with its original weight, its original measurement, and we measure it again, all 4 data points and the weight. And so And we come up, and that's how we come up with an individual unique scale factor for every disc. Now you'll notice something, that if you bought 10 America Smiles Genesis discs from us, it'd be hard pressed to find any two discs with the exact same scale factor. And that's because we actually measure every single disc that we press individually and uniquely. So there are two major reasons why it's hard to find with two scale factors. Number one reason actually is we use 4 digits to the right of our decimal. So when we do a scale factor, a lot of companies just use 1 point and then 2 more digits. Some use 3. We actually use 4. We want to give you the most information possible so you can get the most consistent results. And again, as I mentioned earlier, we measure each and every disc as it goes into the oven. We measure it again as it's coming out. Each disc gets its own mathematical equation. We're able to tell you exactly how much that disc shrank in our possession so that we know exactly how much shrinkage is left for you. Now, I'm not here to speak negatively about other companies, but other companies have a different factor, a different practice, I should say. If they press 100 discs at one time, they may only measure the dimensions of 10 discs and measure the weight of 10 discs. They'll put those 100 discs into an oven. When those discs come out of the oven 4 days later, they may only take randomly 10 more samples and come up with an average. So what they'll say is the average size, the average weight going into the oven was this, the average coming out is that. That's why you'll find if you order zirconia from another company, you can actually order 10 discs and all 10 discs will have the exact same scale factor. We used to experience that before we were manufacturing our own discs. We'd place an order for 40 discs and all 40 discs would have the exact same scale factor. And that's good and that's close and it's close enough, but here at America Smiles we want to do everything 100% as accurately as we possibly can. So how do we actually get that scale factor data? It's actually quite simple. We measure the physical dimensions, we measure the weight. When it comes out of the oven, it is shrunk, so the disc is shrunk, it's gotten smaller, and it's gone on a diet. It actually weighs a little bit less. We put those figures into a spreadsheet. That spreadsheet produces a scale factor. That scale factor follows your disc all the way into the packaging department where the scale factor is identified. So once we know how much it has shrunk, and it varies oven by oven and space location, we do the math and you get a very exact 4-digit expansion factor. Now, these expansion factors, here's the next part we want to talk about. How does this affect your milling process? I mean, who cares if it's 1.2500, if it's 1.2200? Who really cares? Well, it actually does make a difference on how hard it's going to be to mill on your machine. And actually, it comes down to the accuracy when it comes to bridges. So let's talk about this for a second. If the expansion factor is high, like say 1.2500, that means the disc, when it was in our possession, never got as hot as some other discs. And so that means it did not shrink a lot in our possession, which means it's going to shrink a lot for you. Now here's the good news. That zirconia is just a little bit softer. So an expansion factor of 1.2500, it's going to be a little softer. It's going to be a little easier on your tools. It's going to be a little easier on your spindle, a little easier on your machine. The problem is, it's going to shrink a lot in your possession. That means your CAM software is going to calculate the tooth to be bigger in anticipation of it shrinking, and you're actually going to get fewer teeth out of that particular disc. So, but this can actually be a real problem for bridges. I don't recommend milling big bridges, certainly nothing over 6-unit bridge, with something that has an expansion factor of 1.250. That means the disc did not expand very much in our possession. It's going to expand, it's going to shrink a lot. I'm sorry, it didn't shrink a lot in our possession. It's going to shrink a lot more in your possession. You put a 14-unit bridge in your sintering oven and ask it to shrink 25%, you've left yourself prone to warpage. So we recommend, if you're going to mill a larger bridge, go through your inventory, go through your stock, and find a disc that says 1.295. Anything with a 1.2, 1.23, 1.22, 1.23, 1.3. This is, 1.22 or 1.23. This is a disc that's that the majority of the shrinkage is taking place in our possession. It'll shrink less in your oven, and means that the less shrinkage means that you're going to be less prone to actually having warpage. So the downside of this lower expansion factor is it is a little bit harder on the tools, and you will wear your tools out just a little bit faster. So in theory, you might want to mill all of your single units in a higher scale factor. You might want to mill your bridges in a smaller scale factor to prevent warpage. Here at our milling center, the American Smiles Milling Center, we never take scale factor into consideration for any of our single units, but we do seek out low scale factors, or low expansion factors as we call it here, for doing larger bridges. We like something with a 1.22. We find that it's less likely to warp in the sintering oven. So the biggest takeaway here that I'd like to discuss is the actual American Smiles Genesis product. The process here that we have where we measure each one, we don't take averages. Each disc has its own unique measurement. That ensures that you're going to get the exact scale factor to the 4th digit position. I don't think anybody's got a more accurately designed disc than we have. And with so many variables in our industry, from the impression to the stone models and everything else that can go wrong, your tool wears or tool wearing out or your spindle wearing out, so many things can affect the fit of your crown. We want the Genesis Zirconia disc to be that one factor that you can always count on for accuracy. So I want to thank you for listening to this video, and until next time, God bless.